education and research-based platform which helps students to pursue their career in the field of space science and technology. We are on the mission of building the biggest community of space science and technology. We give opportunity to students to work on projects related to space science. Now, coming back to our main event, our topic for today is Human Analoge Space Mission. And today we have none other than Ms. Eleonore Poli with us to pursue their career in the field of space science and technology. And we are on the mission of building the Vice-Curator of GS Cambridge, also the founder of CHASM and opportunity to students and also work career Astronaut Candidate. We are really thankful to her for joining us today. So without wasting any more time, I think we would like to request Ms. Eleonore to proceed with today's topic. Thank you, everyone, and have a nice day. This is all from my side.
Thank you so much, Manish. Welcome, everyone. It's a true honor to be here today for me. I really hope that you'll enjoy this topic. And if you have any questions, I would say it's easier if you put them in the chat for me to then answer at the end, because some of the questions I might answer on the slides after. So don't worry, if you have a question, I will answer it. It's just I will do it at the end. So let me share my screen with you guys. I hope that you are able to see it. Normally it should be fine. So today on my first slide, you see 2 planets, and there's 2 hours going from one another. The reason for this is because we learn from analog space missions, and we take back what we learn to go on to Mars, another red planet, or we also bring it back to Earth. And how, this is what we're going to see today. The content of my presentation today is what are exactly analog space missions. Some of you might know, some of you might not. And there are different parts of analog space missions, such as the habitats, the protocols that we put in place, like safety and hygiene, the life support system, the scientific experiments, but also the analog astronauts and what kind of roles they have. On the picture you see my crew. This was for the mission Astronaut 1, which was a student-led analog space mission that took place in July 2021. This picture was February 2020, actually, yeah, 2020, and it was just at the whole beginning of the adventure. So yeah, just a short introduction. Why am I doing those missions? As said, I'm a Swiss material science engineer, so I'm working at the University of Cambridge, the PhD students, but I was also an analog astronaut and the commander for Asclepios and for Habitat Mate, and I'm the founder of CHASM. So it's the conference on human analog space missions will take place in April. So if you're interested in hearing directly from other members about analog space missions, do tune in into our YouTube channel that will start doing the conference in April. I can send you the link later. But yeah, what are really analog space missions, or what is the purpose? So you might think, well, you know, when we go to space, we have to test lots of equipment. So usually you might not always be able to test the rocket without it going actually to space, you know, but you will test the astronauts, you will test the spacesuits. You know, you have people who are going in pools and they have to get trained into manipulating some objects while being in not without gravity, but obviously like floating. So your movements are a bit embedded, a bit the way they would be in a zero gravity environment. So these are the kind of simulations you can do. But there are very, very important aspects that also need simulating, such as the psychological factors, the foods or the systems that you might need for long duration missions. And this is becoming more and more important with our return to the moon and our possible coming to Mars. Okay, because going to the moon, okay, it takes a few days, and probably you'd stay a few days, you could come back, but actually the money and time investment that we put in it doesn't make it really worth it, especially as we've already been on the moon. So the next step is actually to put a settlement on the moon, and you need to really plan out how this works. And it's quite different from the International Space Station. So on the International Space Station, you can't return in 5 minutes, but you do have usually a Soyuz docked that can then, you know, escape and go back to Earth if there's a problem. When you're on the moon or when you're on Mars, you can't escape that easily, okay? It's already pretty hard on the ISS, it's even harder on the moon or Mars. And additionally, the missions might be even longer. So to go to Mars, at the moment we think it takes about 6 months to go there, 6 months to come back. And obviously it's not right away, and you would probably spend several months or even years on Mars. So the mission durations are even longer than the current ones on the ISS, which usually are between about a month, 6 months, sometimes a year. Okay, so this duration has a massive question mark. Is how do people cope with this? What life support systems do you need? What entertainment do you need? What habitats do you need? Because habitats is also one thing. We know how to do spacecraft, we know how to do rockets, but we don't know how to build a house on the moon. Okay, this we haven't had to do. Okay, and if you're going to have settlements on the moon and Mars, or even a civilization, you don't want to be locked into your Soyuz where you can't even, unbend your knees. Okay, that's not going to work. You need to be able to move around, you need to be able to do different activities, and for this you're going to need a habitat. So this is why it's one of the main focus for Analogue space missions. And there's other focuses, such as the experiments that you can do. So in space, obviously, we test a lot of medication or a lot of systems, and to know what kind of material you need to test them, it's usually nice to test them during Analogue space missions. Obviously, you can also test protocols, or you can test what is the optimal team. Okay, if you're going on a 6-month mission with 5 or 6 other people, it might be worth checking how that team is behaving in an Analogue space mission. And the main thing is because it's way less expensive than going to space, and also it's a bit safer, so you can actually have many Analogue space missions with less budget, with less constraint. Also, people who wouldn't qualify to go to space normally because they have, for example, a heart problem or sight vision impairment, they would qualify for Analogue space missions depending on how difficult they are, how extreme they are. And we could still test somebody who's psychologically perfectly fine, but just have this biological problem, and that would give us massive insight. It means we have a much larger range of people that can participate, and it makes it way more accessible and gives us a lot of data on space research and space exploration. So habitats. Here you got 3 different habitats. On the top one is High Seas. It's a base that is in Hawaii for Analogue Space Mission. On the bottom one is the CHASM Analogue Space Mission, which is an Earth Moon Mass project, and it was basically taking place in Iceland last August in a lava tube. And in the center, it's me doing the space mission Asclepios. We were in a tunnel underground, 450 meters underground, 1.5K away from the surface in a mountain in Switzerland. All 3 habitats have different kinds of, settings. So, for example, the High Seas, they had to build it. For Chill Ice, they were going in the lava tubes that already exist. And basically, they had to pump up a habitat in it and test it. And they had 48 hours to get everything done and do the whole mission. And for me, the tunnel kind of already existed, and we just had several months of preparation where we installed different equipment. But we as astronauts did not have to build our habitats while doing the mission. Okay, so you already have 3 different kinds of setups. And one of the reasons why we might use lava tubes as a good analog for space habitats is because on the moon and on Mars, you will have radiation from the sun. And we need a certain protection for this. So obviously you could say, well, we're going to build, those kind of buildings and stuff, but you're really, really far away. And for the moment, we're not completely able to build from Martian soil or from lunar soil. Okay, so we're looking at 3D printing of these components, but it's not yet working that well. Okay, so for structural things, you do want to bring some concrete from Earth, but it's a lot of weight. Obviously, the more weight you have in your rocket, the more expensive it is, the more complicated it is, yada, yada, yada. So what do? You find a naturally existing habitat on Mars or on the moon. One of these is lava tubes. So they exist in formation and they form those kind of pockets that you see. And they can be really small, but they can also be quite large. And they provide natural shielding from radiation. In addition, if you have those big tunnels, it means you can also have a larger size and comfort. Obviously, the less you have to build, the more, the bigger the size it can be, because you're not limited to material, right? So it's a really, really important thing. And lastly, not only radiation resistance, but extreme environment resistance. Okay, so low temperatures, high radiation, some Martian sandstorm, okay, that can also happen. It's like they're extremely violent when they happen. So you can't have just a tent on Mars that you pressurize with oxygen, okay? It doesn't work that way. All those habitats, you need to test them on Earth before you send them to Mars, because the journey there is just so long, it cannot fail. You cannot afford to fail. And the best way to do this is simply to test it on Earth. Therefore, Analogue Space Mission. But there's other stuff that you might want to test. For example, protocols. So here you see 3 of my astronauts. So on the left, you see Manuela Humble. She was using a dry shampoo. So you think maybe, how is this relevant? But actually, hygiene is really, really important when you do very long space missions. And you need to understand, okay, what kind of material do we take? Because maybe you won't have enough shampoo for 3 or 4 years if you're on Mars. And as much as it doesn't seem relevant, you have to remember you're in a closed habitat with other people. So if you start smelling, it can impact other people and can impact you also, simply like safety-wise, bacteria, infections. It's obviously something that is very, very important and much more important than we think. And you also need protocols for simply cleaning the whole base. To give you an example, during our mission, we had access to running water, so that was fine. But we didn't have hot water, and we forgot the soap. Now you think, well, okay, it's not that important, but we were washing dishes, and we didn't have soap, we didn't have hot water, and we also didn't have a very dry environment. The humidity was 89% and 13 degrees. Okay, and because of this environment, it was quite prone for the formation of bacteria, especially after a meal. And we were using always the same plates. We had 1 plate each, 1 fork each, etc., etc. And this is okay for 1 or 2 days, but after several days, actually bacteria can form on the plates and can then, make us sick. And if we're sick, then the mission is compromised. So this is why we had to find a way to overcome this. So we found some vinegar in one of the experiments we had, and we were like washing the plates with vinegar, and we were boiling the water, trying not to burn ourselves and just dipping the plates in them. So we found a compromise, but it wasn't a problem because it was only 8 days, but it could have been that, I don't know, for example, we wouldn't have enough vinegar for the whole mission or something like this, So this is something that was fine because it was an analog space mission, but wouldn't have been fine on Mars. On the right-hand side, you see Julien Corsin and Sophie Lesmore, 2 of my astronauts too, that are repairing a spacesuit. So there was a damaged spacesuit. Obviously, in an analog space mission, it's not a big problem. But if you are on the moon or Mars, or even in the ISS, and you go out and you have a hole in your spacesuit, you don't have that long. Okay, you will die. So obviously you have to follow a certain protocol. Every time you go on an EVA, so extravehicular activity, and you come back, then you have a spacesuit and you do a checkup, you clean it, you wash it, you check there's no holes, no damage to it, and then you report. You have to follow those protocols because you're probably tired, so you might not remember to do everything if you don't have a protocol that is, written down and you've learned perfectly. But also to protect others, okay? So it's a way to protect you, and it's a way to protect others. And all those protocols for communication, cooking, safety, hygiene, they all extremely important, and they can almost all be tested in analog space missions. Don't know why it's not changing. There you go. So another important aspect of analog space missions and space missions alike is the mission control center. Okay, when you have a space mission, you have obviously your crew that is inside the spacecraft or in the habitat, and then you have on Earth the communication center. And we replicated the same during our analog space mission in Asclepios. So here you sit on the left on the screen. It was me and my other astronaut that we were in the base rehearsing the mission. And here you see the mission control center with a flight plan, Capcom, biomedical engineer, etc., etc. And these are responsible for your safety and responsible for the well-being of the mission. If there's any problem that you cannot solve by yourself in the base, they are there for you. And they are crucial because without them, the mission doesn't really work. One of the main reasons I say this is because you are extremely busy as an astronaut doing a mission. It's almost nonstop. And if you don't have someone that makes your flight plan, so your schedule for the whole day, and allocates tasks for everyone and just distributes workload and helps you when there's information missing or anything that you might need, then the mission is slowing down or compromised or actually total failure. For us, really, they were absolutely crucial in everything. We probably would have made more mistakes, or we wouldn't have been able at all to do everything we had to do. And in addition, for example, if you have somebody who's got a medical problem, you have two people who are trained in health and safety, but they're not necessarily medical doctors, okay? So you have a medical doctor in the Mission Control Center that is here to communicate with you and to tell you, well, yeah, chop his leg off or not, or just give them, you know, medication. So obviously we also have this link, which is extremely important. And this is the same for like normal space missions. Obviously, you have the control center. They can really save your life. So, for example, in the Apollo 13 missions, like they were also really, really crucial. And another thing that you want to test is not only how you communicate between Mission Control Center and the crew, as in like what kind of talk do you give? Like, do you give a straight order? Or do you just blah, blah away? Obviously, you want something that is clear communication, but you also want a Mission Control Center with people who are very calm. You don't want them to stress you out because it's already quite a tough environment. But you also want to test devices, okay? So, for example, we had a phone that could work inside the tunnel. All our phones were not working otherwise in the tunnel where we were, but there was one special phone that was only to be used in case of massive emergencies. We were using TeamSpeak, which is a program that basically you can communicate like each differently to the same person via Wi-Fi. And you just press and you say base to MCC, do you copy? And then they say yes, copy. I'm flight plan, or I'm Capcom, and then you know who's speaking to you. And then you communicate what you need. But you also need to test those devices, okay? If you see that, for example, TeamSpeak is not working well enough for whatever reason, either the delay is too long or the quality of the noise is not good enough. I mean, if we can't understand you because it's too much noise, then obviously it won't be working. And also just how heavy it is for the hardware. You know, is your computer able to run it or not? Obviously, most of those communication devices work really, really well, like there's no problem, but it's still something that you need to test, and you need to create communication protocols for astronauts and for Mission Control Center. And then lastly, one thing that you can test in analog space missions, which is really important, is the delay. Okay, so when we go to the moon, there's a slight delay. But when you go to Mars, there's a 23 minutes delay between communication. So on the moon, you could get more or less a conversation, more or less normal one, okay? On the Mars, you can't. You can't at all. And it really affects, like, people, because obviously if you have an emergency, you're alone for 23 minutes, you know? So you have to work on this, you have to test this and see psychologically how people are handling. And how does it actually affect a mission, you know? And a mission where you can always rely on Mission Control Center to answer in a few seconds is extremely different than a Mission Control Center that answers only every 23 minutes, okay? So this is something that was, for example, tested in Australian Space Forum missions. The last one happened in October. And I look forward to the mission report and seeing what happened out of this. Now, scientific experiments. So here you see me on the left. I was with astronaut Sophie Lismore. We were doing filtration of Martian soil. We were trying to remove what we call perchlorate from the soil, and we were measuring the pH and just making sure that it was fit for agriculture. And on the right-hand side, you see Karen Nyberg from NASA. She was doing experiments on the International Space Station. So how do you go from the person on the left to the person on the right? Okay, or why do we have people on the left doing what the person on the right is doing? The reason we're able to do experiments in space is because we tested some of the equipment on Earth, okay? And basically, on the left, I was using gravity to filter things out. That wouldn't work in space, okay? Some of the devices I was testing also were not as efficient as we needed. We learned a lot from that experiment because the way it was designed was with more expensive equipment than what we had in the base. So it took less time when it was made in the laboratory. We had different temperature conditions. We had different level of stress or, of maneuverability. And that really impacted the experiments. So we managed to do what we had to do. But I know that since we rehearsed this and we did it in the Analogue Space missions, it wouldn't work that well in space. We would have to modify quite a lot of things, quite a lot of equipment for it to fit in space. And this is exactly what you want to do in Analogue Space missions, that you don't need to be successful from the first point. You need to test to see what you need, what extra, even a ball, like you don't think about it. But for example, we were missing a magnet, so we had to make a makeshift magnet. It doesn't sound relevant, but actually when you're doing experiments that can be highly precise, every little equipment counts, okay? So it's much easier to test it in an Analogue Space mission and see, okay, well, this are definitely things that we need to have, rather than send everything to space and then in space you're like calling back and say, hey, actually we're missing this, and we don't have them on board, okay? So testing those experiments is very, very important because it also teaches us, okay, are the people on board well trained enough to perform them, and do they have the right things? For example, I'm a material scientist, so I'm used to working in the lab. It's not a problem. But we had one of our astronauts. He was a computer scientist, and obviously he's not used to working in the lab, so he can learn. But if you give him equipment that's too complicated, he might have difficulties operating it, or he will need a much stronger protocol. These are all the things that you basically will try to understand when you do an Analogue Space mission. Now, okay, not working again. There you go. So, life support system. Sorry, it's a bit of a blurry image, but I thought it was quite a nice image. So, on the bottom left, you have what we call the ice cream sandwich for astronauts, and it's kind of almost of a joke, but it's sold by NASA, and it's a freeze-dried meal. I personally really like freeze-dried meal, but during our Analogue Space missions, we actually had fresh food or we had canned food. And here you see astronaut Suta and astronaut Lismore cooking together. So every day you have different people who are located with the task of cooking for everyone. And it can be really beneficial. First of all, some people have problems when they don't eat enough or they don't eat well. It really impacts their mood. I'd rather not be locked up in a base with somebody who's got a bad mood when they're hungry, but you don't usually see this on the CV or in the tests, okay? So there's a limitation to what NASA and ESA can, prepare an astronaut. And the other thing, it's you need this energy and you need this kind of moment where you're all together and you're cooking and you're making something for the crew, okay? So cooking and food in general is actually super, super important in Analogue Space missions. And for example, if you give a crew for 6 months freeze-dried food, or if you give them fresh food, how much does it improve their performance and also their physiological data? Obviously, your body will absorb better fresh food, like fresh vitamins and things like this, rather than supplements. And it's something that if you're going to spend 3 or 4 years on Mars, will be extremely relevant to understand, okay? If, for example, we do realize, okay, yes, your body really, really needs only fresh foods, and after a year, like freeze-dried food is really detrimental, then, okay, well, one of the priorities we're going to have to do on Mars is to have plants growing, okay? Not just for oxygen, but also because of food and because of just physiology, okay? Other life support systems, for example, CO2 levels, water recycling system, air filtration and pressurization of the base. This really depends on the Analogue Space missions. Some space missions have habitats that are really closed off, and they can monitor that kind of thing. Others are a bit more limited. For example, we were checking the CO2 levels, so we knew, for example, when we were doing exercises, CO2 levels would go a bit up, but we were not in a closed space, so it was never extremely dangerous. It's just we needed to monitor them just in case there was a ventilation problem, etc., etc. The other thing we had were radiation levels. So because we're in a granite base, basically it has a small radiation emission, and we're just always measuring them in case we were receiving too high radiation levels. Air filtration and pressurization also depends, again, if you have a habitat that's closed off or that has an airlock, then you will check that kind of thing. If not, no. I think that it's not always necessary, and it really depends on the goal of your space mission. If the goal of your space mission is to really make people feel that they could be in danger potentially, then having a pressurization system could be very, very interesting, because there people know there's a real danger. If there's not equalization, or if there's a problem in the habitat's integrity, then they would be put in real danger, and that changes psychologically the aspects. But one thing that you have to understand is analog space missions don't always have either the budget or just the support, and this impacts directly how ethical they can be. Okay, for us, for example, lots of our experiment had to be approved by the ethical committee, and if they said no, then we were not allowed to do some of the measurements. So, for example, some blood tests we could not do simply because it was not ethically approved. Okay. So, the big question, analog astronauts. So here we see the base. This was for the mission Astronaut 1, and we were just in the tunnel, and this was our airlock. On the left is the toilet, on the right side is the airlock, and then you have one tunnel up, one tunnel down, and we had to always ask before coming in or coming out. So normally you would have the full helmet on, but how did we get there? Okay, so we didn't just go from the tunnel right away. We first had a recruitment process, and the recruitment process depends a lot on the analog space mission. For example, for us, it's mainly on what the European Space Agency does, which is you first start with a CV and motivation letter, and we check your motivation and we check what kind of experience you have. Some analog space missions are really, really tough, others are not. Astronaut, they really check if you are able to work in a team, if you're athletic enough, so you don't need to be, Olympic athlete, but you need to be able to, carry stuff and be under some strain and some stress without your body crumpling. You need to be obviously super motivated and in love with space. Like if you're barely interested in space, then it's probably not the right thing for you. And you need to be also able to communicate quite well. A bonus is if you have any experience in extreme environments, because then we know how you react in very stressful situations. Then you have a video to assess your motivation. You have a short psychological evaluation, so we kind of see your motivations at intrasec, extrasec, and then we test your English skills. So if you're enabled to speak English enough that we understand you, then it's going to be problematic, because most analog space missions are very international. You have people from different countries, and if you can't speak English or you can't speak at least one of the common languages, then it's not going to work. Additionally, often the Mission Control Center will talk to you in English simply so that we can record everything, and then it's accessible to the general public. So English skills are obviously quite a big thing. Then you have cognitive tests and also extra psychological tests. And the cognitive tests are not only to see if you have, average intelligence, but also if you're able to keep focused in a long time, okay? And once you pass this, you have a psychiatric evaluation. So you sit for half an hour to 1 hour with a psychiatrist, and they will tell you if you're fit to be in a base. Because you might not know, but it could be that, for example, you would have a psychotic breakdown or have just a problem, and you are with other people and you are not in a normal environment. Like for us, if the ambulance needed to come, it would take at least 20 minutes for them to arrive. So we can't have someone who suddenly becomes totally crazy and, starts strangling somebody else. No, we can't afford this. And you would have a psychiatric evaluation if you were an astronaut anyway. So you have to go through this. Then we do a fitness test and a teamwork skill. The teamwork skill is basically we put you with other candidates, and we check how you interact. If you're a person who's only a leader, like you can't follow anyone, you have to lead in any case, it doesn't work. Okay, every astronaut at some point in the mission will have to lead, because each of them have a different set of skills. Okay, so even if you're not, the expert in something, you try to take this leadership away from the real expert, then you are not effective. You are not helping, you're actually sabotaging the mission. So this is some things that we need to see. And you can see, for example, are you rude? Are you interrupting? Do you have good listening skills? And also, do you like working in a team? If you are on the side and not talking to anyone, then it's very unlikely that you're going to enjoy yourself in the mission, and the mission will be compromised again. Lastly, one of the real highlights of the recruitment process, for Astronaut at least, is we had an interview with astronaut Claude Nicollier. So Claude Nicollier is the only actual Swiss astronaut, and he's been supportive of the mission. And I think some of the Analogue Space missions would have like either astronauts or members from space agencies interviewing you. But we had really a one-on-one time with him, and that was really, really cool. So yeah, actually it's him on the right-hand side. So basically he was one of the mentors for the space mission. So one thing that is really important when you do a space mission is to make people understand why and how they're doing this, and to have the right people guiding you. Okay, so Astronaut, for example, was a completely student-led space mission, but we had mentors such as Alban Michon, who's on the left-hand side. He's a French explorer. He's a professional diver, ice diver. Actually, he went to the Arctic alone for like a whole month. And on the right-hand side, Claude Nicollier, that was him repairing the Hubble telescope in one of the space shuttle missions. Okay, both of them have been amazing mentors, still are, and they really help in us first understanding and preparing for extreme environments. So for example, Alban Michon, he told us how to build igloos, how to survive in tent in the cold, how to really become. And Claude Nicollier was like teaching us about space, about leadership, about how to love and how to prepare for the mission, what rules we would need in the mission. So this is also one very important thing about Analogue Space Mission. Have somebody that, you know, guides you through it. Now the training. So here you see a very sexy picture of me. I look extremely smart on this. And so it's me on the right, and on the left is my astronaut, Sebastian Galle. And we were doing extreme environment training with Alban Michon. We were in the mountains, and we were doing ice diving. It was first time ice diving for me, and we're doing it by night. And it was really, really amazing. It's an extremely good training because you have to collaborate a lot. So you have to communicate with your fellow analog astronauts. You get to meet them, you get to push your limits, and you get to trust them, you know. So for example, it's very difficult to get out of those suits alone. So you need one or two people to help you to get out. And it really just creates a bond, you know, when you share your food, or you have to make water out of snow really quickly, so you two people kind of punching some bags of ice to get the water out. It just makes amazing memories, and it really reinforces your crew and prepares you for the mission. Now, another training that you need to do is the base maintenance training. So once you have your defined habitat, your defined base, what will happen is that there will be lots of shutdowns, and there will be some problems. And if you can learn how to repair your base, it's actually a massive win. For us, we couldn't really visit the base, or at least prepare the base ourselves, the astronauts, before the mission itself, which means that during the mission we had to learn a lot and find out a lot of things on site, and it made it a bit more complicated. Really enjoyable too, like it was cool to repair on base. We had the electrical problems, for example, and water problems, and every time we fixed one, it was really, really cool. But at the same time, it was also a lot of time that was wasted. So if you can get the base maintenance training, which is usually the case, then it's a really, really good bonus. Now, psychological training, a good team is a good mission, okay? If you have friction between team members, it can be really problematic. So you either need to solve it, or you need to be able to deal with it, okay? So you don't need to love everyone, but you need to be empathetic enough, understanding enough, and calm enough that it won't create a problem in the long run. And the same for leadership training, okay? You take the lead on your own task, and you don't want any micromanagement, okay? Astronauts have to be independent. They have to be, know what they're doing and proficient. And you don't need to tell them what to do all the time, but sometimes they might need a bit of guidance, a bit of support. Again, because it's a stressful environment and it's a lot of work to do. Communication training, as mentioned before, it's nice to have a protocol. It's nice to communicate clearly. You save a lot of time, and you could save potentially lives depending on the mission where you are at. And speaking of lives, you also need a first aid and hygiene training. A sick astronaut can really compromise the mission. Several sick astronauts will abort the mission, okay? You can't afford to have people contaminating others, or you don't want to have to cut anyone's leg or have any other problem. So if you have a small problem, everyone is trained in first aid and can save the other's life, or can try to at least, and it'll try to maintain them alive until the ambulance come. And also everyone is clean enough that they wouldn't risk infections or other sort of problems. Lastly, to your other trainings, public speaking. Why public speaking? What do you think? It's actually quite funny. Analogue Space Mission usually requires sponsors, or they require visibility. And astronauts are usually the figure of Analogue Space Missions. Sadly, you don't see all the people that are doing the work of building this Analogue Space Mission. For Astronaut, we had over 80 people working on the project at some point, and all students, and they would put 5, 10, 40 hours per week while doing their studies to make this happen. And then if you look in the newspapers, there's maybe 2 project leaders and then only astronauts. They don't see the people that are behind the work, which is sad, but it also gives astronauts a responsibility to represent the mission. For example, for Astronaut, we were completely depending on sponsors and crowdfunding. So one way we had to find people was we had to show them the base, we had to give speeches, we had to talk to newspapers. And if any of us was bad at public speaking, then it was a problem, because obviously then nobody wants to listen to you, you have less coverage, and then you have less sponsors, because sponsors are like, well, actually, no, you're not good in the newspapers, nobody's interested in your mission, so I don't have any visibility, so I don't want to give you any money or any product. Okay, so this is why this public speaking is the only way we had to repay people for the work that they did for us. So it was very, very important. And in astronauts in everyday life, it's actually important too. So it's funny because it's not a training of a real space mission itself. I mean, astronauts have to public speak, but it's not as dependent as for us. Like for us, Astronaut doesn't exist without public speaking. So very, very important thing. And then lastly, nutrition training, more important than you think. A good mood, good food means also a happy team and a good mission. In other words, several roles. So the roles of astronauts in Analogue Space Mission depend a bit on what kind of space mission you're doing, how long they last. So some missions are like a month long, some are just, for us, it was 8 days, others 24, 48 hours. So you don't always have the same needs. But in general, this is the structure that works. So you have a commander. In my case, it was me. So my role was to look after the crew and mission's well-being, and oversee any evacuation procedure. So basically, if everything goes well, if people are doing their work and everything is on time and everything's working, I don't have anything to do. But if there's an emergency, or if there's a conflict, or if there's any problem arising, then I have to give the orders. I have to manage people, and usually you have problems from the beginning, okay? There's stuff missing, or maybe the crew is a bit tired and they need support, or they're doing something weird. So you actually always have something to do, but it's never very, hard or difficult unless you're really unlucky. I mean, it's an analog space mission, so it's usually not as bad as in a real space mission. But still, it's important to have a commander, just because you need to have one person that takes this leadership. Then we have a communication officer. So usually they ensure communication equipment is functional. So if you don't have a communication with Earth, then you can have obviously a mission that can be compromised. So they check basically the Wi-Fi is on, or any form of communication that we use is working, and they also do a data backup. If you do a 6 months mission and then all the data of the scientific experiment you did is missing, then you lost quite a lot of time. Okay, so it's something that you have to do. Then we have health officers. Usually it's good to have at least 2 or even more, depending on the size of your crew, and they will not only just take crew vitals every day to have an idea of how we're doing, but they will also assist in EVAs in case of any injury. Why EVAs? I mean, in EVAs, you're wearing a spacesuit, okay? So usually it's a bit foggy, or you can't see super well. It's a bit warm. You know, a bit like this bonhomme Michelin, not walking really, really well. Have problems maybe being a bit nimble, okay? So you might trip, you might fall, and you might hurt yourself, or you might get dehydrated, you might get more exhausted. Something can happen. So having someone on standby in case of an EVA is actually very useful, because it means that the astronaut that is doing the relay to those astronauts outside of the base can directly ask the person, okay, what would you recommend? Do you think we need to check this, etc., etc. Then there's a payload officer. So usually they're the person responsible for scientific experiments. So they will check the protocols, they will check the inventory, they will check the experiments are going well. Obviously, that again depends if you have a lot of scientific experiments, because if you have experiments that are more like biology and others more material science and others more, I don't know, electronics, you have people with different backgrounds and they might not be able to know everything. So there you could have several people who are responsible for that. And then lastly, a base engineer. They're there to ensure the integrity of the base. So if there's, for example, problems, an earthquake, something like this, they would check the base, or they would check any system, like life support system, are working, and report to the commander and the mission control center. So, what is the key to a successful Analogue space mission? It's safety first, mission second. Okay. Like if your crew is in danger, or if you're going to be sick, or if you're all going to die, there's nobody to do the mission. Unless you're working with robots, in which case, you know, like you didn't need humans in the first place. Okay, so always put safety first and then mission second. Secondly, work with passion and quality. If you do your job well, nobody will have to do it a second time for you. We win a lot of time, and time is precious in space missions. And if you work with passion, you do a good job, and you'll also enjoy yourself more, and the mission will be a wonderful time. And therefore, enjoy. Here you see our Capcom, Christian Cardinal. He was also an astronaut for Ascapus 1, and he was really helping us to work with passion and quality. By giving us, you know, a nice briefing. He was very, very efficient, but also in a good mood. Here's just to entertain you guys. So here was myself and astronaut Julien Corsin. We were just about to go on an EVA. We were supposed to take some pictures, and we were recording about everything we're doing. Here you can see the airlock. Here you see a bit of the food storage. So all the food that we had was labeled, and we had an inventory. This inventory allowed us to see if we had enough food, allowed Mission Control Center also to know if we had enough food, make sure that we were not eating anything that was possibly like not ours for some reason, or could be damaged, or could be unsafe for us. And made sure also that we had healthy meals and we were keeping good shape. On the bottom left side, you see a plant. This was one of the plants that was given to us. This one was Claudine, given by Clony Collier. It's nice to have plants, okay? We were in this tunnel made of rocks everywhere. Having something green keeps you in link with Earth, basically, with life, etc., etc. So having those plants was not as part of an experiment. It was more as part of a kind of well-being, and every morning I would take the plants and I would put them in front of my crew, and they would like touch them or they would sniff it, so to kind of get the smells and aroma of, you know, the outside world. It's a very good connection. I think it's a very good psychological help to have plants. Even if for us we're just 8 days in the base, so it's not a big influence. In the center bottom, you can see Sebastian Ogalde. He's calling his family. So family time is something that is also important, okay? Obviously, you're working a lot, so most of the hours you're actually busy. But a few times during the mission, you are allowed to contact your family or your friends or anyone you want, really. And it's a good connection back to Earth. Sometimes you forget. You isolated not in the way that you feel lonely, but in the way that you've really focused on the mission. And having this break and going back to the outside world, it can be really motivating, because it allows you to take a step back and think, oh yeah, yeah, I'm doing this, and people are actually watching or enjoying, or it's helping outside. And then on bottom right, displaying a wonderful cardboard moustache was our other Capcom, Aubin Tozanti. And he was doing the morning shift. So every mission control, we had 4 shifts, and 2 of them were actually talking to us during the night. And Aubin was doing the morning one, and Christian was doing the afternoon one. And they were like, they had trained with us as astronauts, so they knew exactly all what we had to do, and they could help us in every of the objectives that we had. And they were a wonderful, wonderful help to us. And lastly, I have another slide for you guys. The left-hand side, you see the crew. This was the last night of the mission. You see James, our second plant. On the right-hand side, you have the 2 project leaders, Chloe and Elfie, who founded, created this project and led it wonderfully. Left-hand side, you see some of the people that helped make this project happen. So this is only a little part of it. So you have to understand how big an Analogue Space Mission can be. Bottom center is one of the extreme environment training we had, as well as on the right-hand side when we're just having fun. So yeah. This is the end of my part per se, but if you have any questions, then I'd be very, very happy to answer them.
Yes, so thank you, ma'am, for this wonderful presentation. I think now we can move forward towards our Q&A session. So as I can see, there are a few questions in the chat, and also, if anyone else have any other questions, you can raise your hand. We will be unmuting you one at a time, and you can ask your question.
Should I go through the chat?
Yeah, sure.
So, all astronauts needed to undergo the filtration process. Analogue space missions are not a requirement to become an astronaut. And once you are selected as an astronaut, for example, by NASA or by ESA, what you will do is some form of analog space mission. So you will do extreme environment training, you will do like diving in the pool with your spacesuit. So you will do some aspects of it, but you probably won't do a full analog space mission where you test the habitat at the same time as the extreme environment, at the same time as the crew, okay? Because they have really, really high skills to do. However, it really helps your CV. So when you apply to become an astronaut, the fact that you're an analog astronaut shows that, you're happy to spend your holidays being in a tin can with other people, okay? You don't have the same, motivation as other people. It means you want to do one step further. And also it means you have experience in this environment. Like, are you the kind of person who enjoys this? Are you able to work in that kind of environment? So obviously it's a plus, even if it's not a requirement. So about chemical experiments. I'm not sure about your question. So chemical experiments can be carried out in microgravity conditioned space. So the thing is, on the International Space Station, the experiments that you try to test usually are the ones that are due to the lack of gravity. Okay, for example, all the medical tests that we do in space are testing what happens when we don't have gravity or when we have less gravity, okay? So for example, your bone and muscle density go lower, your vision is affected, those kind of things. And it's the same, for example, when we do 3D printing and you don't have gravity to press the pellets onto one another, how does this affect the kind of, material printing? So these are the kind of experiments you want to do. If you have some experiments that are like, they don't really change or they can't work in microgravity, then you're not going to test them out, basically. So I'm not sure which kind of chemical experiments you would like to do. Probably one where the vapor pressure is quite low and it evaporates, etc., etc. But I think volatile experiments anyway would be a hazard on the ISS. They could possibly happen on Mars, for example, where you have a bit more gravity, but it would probably depend on the kind of chemical that you have. So it's very difficult to find out planets which have similar situation like Earth. We are born and grow up here, so which kind of technology is used to, I guess, to adapt is what you want to say. What's the plan for multiplanetary life and how is it going to be possible? Well, the plan is to do analog space missions to see how we can adapt. Basically, when you do analog space mission, you test habitats in extreme environments, okay? And the extreme environment can be the moon or Mars. And once you know that these habitats work, then we can put them in. So this is how you adapt. You test on Earth and then you bring it to space. We don't know yet how we're going to adapt for everything. You know, for example, we still don't know if we can have children in space. You know, is your child going to be normal? We don't know this. Okay, it's something we probably won't be able to test until we get there. But most of the aspects from habitats, from the food, from psychology, we can test. There's only one other thing we can't test except giving, for example, birth and your child growing up, is how will we react when we see the planet so far away. I mean, when we're on the moon, we can see Earth. You know, we see it and it's beautiful, etc., etc. When you're on Mars, you don't see Earth that well. Okay, it's more like a dot. Psychologically, we don't know if we're actually ready for this, and this is something that an analog space mission is quite difficult still to replicate, because even if you simulate this as much as you can simulate the extreme environment, but you can't necessarily simulate the distance. Okay, you can feel that you're far away, but you're still on Earth, you know. Okay. Which known planet is the most suitable for this? I do not know. I mean, it depends if you talk about a planet that is suitable as in accessible, or a planet that is like us. There are a few exoplanets we know that seem to have a life suitable condition as life as we know it, but they're not accessible. Okay, so that's the problem. It's like, are you talking 10 years or are you talking in 200 years when we've got, you know, better space technology or teleportation? If you've got teleportation, yeah, then there's better planets, and we haven't found them all yet. But in our solar system, in our moment, obviously it's Mars. Okay. Okay. Okay, so Pranav Yanyani, you can write me an email and then I can like just reply to your question if you want. So my plans for the future and analog space mission working for ESA. So I'd like to become an astronaut. So I'll apply in the next selection. And for analog space mission, for me, I would like to go to the Arctic Circle to work on analog space mission there, and the Utah Desert and the MDRS research station. So these are basically my plans, but I haven't applied yet because I'm in my final year of PhD, so I need to finish this first. But yeah, this is the plan for me. So there isn't any sorts of doctors on the ISS, but can nanobots be a good drug delivery, or is any sort of surgery in space for the astronauts? So actually astronauts in space do receive very, very intensive training. So some of them have to do some minor surgery or dentistry. Nanorobots could be a good drug delivery system, I guess, but I don't see why it would be more efficient than, you know, normal drug delivery system. So, you know, astronauts, they have to take their own blood, they have, you know, to do lots of medical procedures that you would think are inaccessible, but actually if you train to do it, it's fine. So they are actually way more trained than you and I, unless you're a medical doctor, to do those procedures, and they don't need probably robots for this. It could be, however, now that we're using robots on the ISS and there are robot surgeons, that they would choose to use a robot to do a surgery. Okay, so you have robots that can be either like working by themselves or they're controlled by a surgeon on Earth. And this robot is very, very nimble, probably much more than an astronaut who's not medically trained, and they could probably perform the surgery. But then there's again the question, if you have a time delay or if you have a communication problem and your robot just stops in the middle, what do you do? Okay, so these are all the things you have to see. For the moment, nobody had to get a cut leg in space, so we're very lucky. How can you work for it? So you can apply to Analogue Space Missions. Just have a look onto like several links, see when they, either you can apply as an Analogue astronaut, or you can volunteer, or you can say, well, I'm interested to, I don't know, work in the mission control center or in the logistics or whichever aspect. Just, send your CV or ask anyone. There's several Analogue Space Mission available. So have a look what fits you best, and yeah. My mission base was based in Switzerland in Grimsel Pass. So the Grimsel Pass is kind of in the mountains. So the pass itself was at 1,600 or 700 meters altitude. And we had 2 lakes, and we had dams actually on those lakes. And we were under this. So 450 meters on the ground. And to get outside, you had to walk 1.5K. And if you continued on the opposite direction, you would get to the to the dam kind of engineering center and powerhouse, and on the other side you had a nuclear waste storage research center. So it was actually really, really cool. If you do research or if you're an engineer, I think it's a really amazing site. I'm going to put in the chat. The name is called Grimsel Pass. There you go. And the center is called Nagra. Okay, then what is the full form of EVA? So I'm not sure what you mean by this, but I guess you mean how does it happen? So for an EVA, what happens is you plan it with the Mission Control Center. So usually it's either on your timetable for a week, or, for example, the schedule, an extra one to tell you, okay, astronaut, blah, 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 blah. You are on EVA, this person will be your Capcom, and your EVA will last this much time, and the goals are this, okay? So you receive your goals. One astronaut will serve as communication inside the base, and you have walkie-talkies and stuff like this. You put your spacesuits, and you follow a procedure when you put them to make sure that there's no problem, that they're not damaged. You check each other's communication, you do a radio check. Once you're ready, the astronaut in the base that's helping you will communicate to Mission Control Center. They say, okay, base to MCC, do copy, and they say, base, we copy. Say, astronauts, blah, 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 ready for EVA. Do we have approval to go into the airlock? And they say, yes, copy that. Then you get in the airlock, you close the airlock, then we do another radio check, etc., etc. Then we get outside, then we do the EVA, and then when we want to get back in, we do again a radio check. We say, okay, EVA to base, do you copy? Yes, EVA, we copy. Asking permission to get back into the base. So why do we do this? Is because you need to make sure that the airlock is closed on the other side, okay? Otherwise you would have the pressurization. So yeah, so this is basically what happens during an EVA. And then the EVA depends on what you do. Like we had EVAs to check on the leak. We had EVAs to go and take some pictures. We had EVAs to do geological experiments. So there were different sorts of EVA. So yeah, I hope that answers your question. And I don't see any other question per se on the chat. You can add me on LinkedIn. Yes, but I see some hands are raised. So I don't know, Manish, if you want to mute specific people.
Yeah, sure. I think Sakshi Singhal has raised her hand. So yeah, Sakshi, I've allowed your mic. You can ask question now.
Thank you, ma'am, for an amazing session. I just wanted to ask, how do you create fake gravity conditions, like less gravity on Earth, for analog space missions?
So the only way you can do this is usually with water. Simply. So this is the main aspect that we don't really test in analog space missions, is this microgravity condition. But you could do it obviously with aquanauts. And when you simulate habitats that are submerged into the water, or that you have to wear a spacesuit in the water. For example, during our extreme environment training, we did, as said before, the ice diving. During the ice diving, we were under the ice, and you have this dry suit, which means that you keep dry inside it. You just have your face, it's a bit wet and very, very cold. And they turn off the lights, and they kind of made us feel as if we were in space floating, because it's all dark. It's cold, and there's no noise. And it was one of the most beautiful feelings because we were like, oh my God, it's like we're in space, you know? But obviously you can't spend hours like this, okay? So this is the one thing that we can't do, but there is actually way many other stuff that we can do, okay? So on the International Space Station, they test the microgravity part, and then in analog space missions, we can test a really large part of space missions. I hope that answers your questions.
Yeah, thank you, ma'am.
You're welcome. So looking, I don't know if anyone else has questions.
Well, yeah, no one else have raised their hands, so I think no one else have any other questions. So firstly, thank you, ma'am, for this wonderful presentation and helping us out with this topic. And again, thank you for spending your time with us. And also thank you to all the participants for diligently supporting us and making this webinar a successful one. So thank you, everyone. And also for the certificate of participation, I'll be sharing the link on the chat of this meeting and you can fill it up. And this meeting will be on up to 8:30, so you can fill up within that.
Thank you so much, Manish. And really, so if you guys have any question or you have you want more information on the space mission, you can send me a message on LinkedIn. I'm sending also just you can put my name on YouTube. I have a YouTube channel where I talk about space, about analog space mission, and where the conference will be published about different talks from space missions. So really, just fire out. Analog space missions are really wonderful. If you not sure if you want to go into space or work in aerospace, it's a really wonderful way to take part in projects. So really go for it. And thank you for the wonderful messages. Thank you, Hex-Star Universe, for inviting me. Manish, thank you so much. It's been lovely. And I see somebody has a hand raised, so I don't know if it's an extra question or if everybody wants to leave. I don't know.
Yeah, someone else have raised her hand. So if you want to ask, I can allow her mic.
Sure.
So Gargi, you can ask your question now. I've allowed your mic.
I just want to thank you, ma'am. The session is so amazing and inspiring. I don't have any questions. I just want to thank you.
You're such a sweetie pie. Thank you so much. That is really lovely. Yeah, and yeah, really don't hesitate if you change your mind and then you want to ask a question. Now it's the other hands raising. I don't know if suddenly everybody wants to ask questions.
Purushottam, do you have any question? Then I will allow your mic. So.
Hello, ma'am.
What you know about rolling down?
Nice music.
Hello,
I don't know if that was on purpose. Do you have a question?
Yes, ma'am. Ma'am, this was very amazing sessions. I am here about. And ma'am, one question: how can I work for it, like astronaut and anything human analogy?
So as mentioned, you just have to apply. So I can send you here some link. For example, askapos.ch. You can type Austrian Space Forum. Also, they are some of the most amazing space missions. Euro-Moonmas also are one of the centers for space missions, as well as high seas, the pictures you've seen before, MDRS, FMAS. All these are analog space missions where you could try to apply either as an astronaut or simply send your CV as a volunteer. Askapos is a student-led program, so if you're a student, then obviously you have a bit more chance to apply there. But for example, the Euro-Moonmas project is partially also led by students, so it shouldn't be a problem for you to try and apply. And yeah, best of luck. Really, just put analog space mission on Google and look into the ones that also apply the best for you. Because, for example, some missions are a bit longer than others. and they might not work for your timetable, okay? So you just have to look what works best for you, what roles you want to do. There's lots of stuff you can work in finance for it, or, you know, photography, or as astronaut, as engineer, as a manager, and yeah, just apply.
Okay, ma'am. Again, I am thank you. Such an amazing sessions.
Thank you, and good luck.
Okay, ma'am. Thank you.
So can someone work in the corporate world and take part in mission? I guess by corporate world, you mean like more kind of business or finances. I personally, so I'm doing my PhD while doing analog space missions. So it's just like, it depends on your timetable, right? So as I said just before, pick the analog space mission that you want that fits into your program, okay? If you're going to be away for 6 months, then maybe your job is not going to be super happy about this. The other thing is your qualifications. So you don't need to be an engineer or scientist per se to be an analog astronaut, but if you are not able to do scientific experiments, so like if you don't understand at all, like that you need to clean something and that you need to be putting something precisely, that's a problem. So you can be from the corporate world, but you have to be able to multitask, to be able to do lots of different things and be interested in a lot of different things. And you need also to make yourself available. I, for example, I think that doing this analog space mission was one of the best experiences of my life and extremely good for my CV. But I know some people who decided that they wouldn't continue with the space mission because their work was going into the way. Okay, so it really depends on your own priorities. And Goran, you say, can virtual reality be used to simulate space environment and simulate it for astronaut training? So yes, and even Thomas Pesquet, one of the astronauts, was actually using this in space recently. When was that? A few years ago, I was working at the Swiss Space Museum, and we had an Oculus Rift, so there's VR sets, and we had the ISS simulated, and it was so cool. It was amazing because you could really visit the whole ISS, and after 3 or 4 days of working there, I knew it by heart. It was perfect. It was my home. But what was really interesting is that, you know, you had to pull yourself to travel, and unlike other VR sets and VR games, you have gravity. So you have up and down. But in the ISS, you don't have gravity, so you don't have up and down. So you had people turning their heads all around, and some of them were actually getting sick because they were turning too much and they were getting confused. So yes, you can use virtual reality. I think it's a really good thing, especially if you have habitats that are really far away and you want people to get used to where things act really rapidly and calculate how much time every activity takes. Yes, virtual reality is obviously a very good thing, but it also has its limitation. And yeah, so my YouTube channel is just my name and full name. So like there's only a few information. I just started it. It's not amazing. It's just extra information if you need. There's lots of other people who do really amazing stuff. So you can also just put Analog Space Mission and you'll find interesting videos. A VR asset that could be used underwater. Yeah, it could help. Yeah, that's true. Oh, so what if we make an extreme robot that has minds that could be controlled by people on Earth so that we can build a safe living place on Mars for humans and live protected from radiation? Yeah, so basically we are sending robots first to Mars, okay? So the plan, if we go to Mars in the coming years, we're going to send a lot of robots. They're going to do a lot of mining to extract some materials that we might need. They will start building for us. And then we're going to, you know, live there. But one thing you have to remember, we can't communicate that well because of the 23 minutes delay, okay? So it takes time for the information to send. So the best is to actually just program them to do the thing on their own. If we're remote controlling it all the time, it's going to be a really, really long mission, okay? It's planned to use robots to do quite a lot of the work. But to also use those robots, you need to know what habitats you want. And this is why we do also those analog space missions, is that we have to test the equipment first before we tell the robots, okay, now you can go and do this. Adash, I'm not sure about your question. What if we send one human at one go? You mean one human after the other? Or do you mean humans without having robots first? Yeah, so it's like if you have humans on site that can, control the robots, then it's good. But it doesn't change much of the problem. The problem is this, the first crew you're gonna send on Mars is gonna be like, if they don't have already robots helping them, they're gonna have a heck of a mission. Okay, it's gonna be really, really hard. That's why we're not sending robots because we're lazy. We're sending robots because it's gonna be really a tough job to get a habitat sorted. Okay, you just come back from a 6-month trip from Earth. You're far away from everyone, and then you have to pilot the robot to do everything they could have done probably without you. So yes, I agree. Obviously, if you're human, you can see everything that's going on, etc., etc. But if you feed the right data into your robot, it's very unlikely that it would sabotage the mission anyway. Okay, so yeah, robot and human together, obviously, it's the best option, and there will be a combination of everything. So the robots are not going to do everything. Okay, so lots of humans will then do the rest of the habitats. Elon Musk said 2024 on Mars. I think it's going to be 2024 on the moon. Again, maybe next year, not sure. It's more likely it's going to be 2030 for Mars. I think the pandemic has slowed down things quite a lot, so we have to kind of recede those numbers. But it's very possible that some other countries in the US or Europe will get on Mars before, but I don't think it will be by 2024, and the main reason is because of those habitats and the technology that's not 100% ready. Like, it's better to wait till 2030 and the trip takes you 1 month to get there, and then you already have a house there, than go on 2024 and it's very likely people are going to die because nothing is ready and it takes months to get there. Okay, so we'll see what happens. I can't speak for him, so yeah, maybe we'll get there by 2024, but I really don't believe so. Okay, I don't know if there's one more question or if everything's fine. So Umesh Kumar, you have one question. I don't know if you want to say something.
Yeah, sure. Sorry, ma'am, for the music, and yeah, I'll allow Umesh Umesh's mic. Yeah, Umesh, you can ask your question.
No problem.
Yes, okay. Thank you, everyone. Thank you, ma'am, especially for providing us such a wonderful session. And my question is that, galaxy is just a stationary. So why do scientists say that it is rotating? Right? There is something reason. Definitely some practical reasons behind that. So I just want to know that.
Sorry, you say that galaxies are stationary?
Galaxies looks stationary, but why do scientists say it is? It's rotate.
I'm not an astronomer, so I'm not going to answer that question.
But it's okay, ma'am. No problem.
Don't worry. I'm sorry, but I don't have the right training to answer that question. So
it's really encouraging, ma'am. From your session also, it's really wonderful,
sorry?
and we just. It's really encouraging, ma'am. These types of sessions definitely encouraging all of us. So thank you for that.
You're welcome. Wonderful. So I don't know if you have more questions. Manish, so do let me know if we need to close the session or if we have more time. Like, really, just let me know.
We will be here for up to 8:30 because of the form participation. They will be filling that up. So if you want, you can stay and answer their questions. But if you don't have time, you can leave the meeting. And
yeah, so I'm gonna stay another 5 minutes. Then I have to go to my machine to do some experiments.
Yeah, sure,
so,
sure.
I don't know.
Sure,
Okay, so you must see. Sorry if I misspell your name. Studying engineering. So there's an entrance exam to become an astronaut. So yes and no. It's not directly an exam per se that you don't sit down and then write something. It's all the steps that I mentioned before. So you have this. You send your CV, motivation letter. Then you have, we check your English, then you have those cognitive psychological tests. Then, for example, in NASA's case, it's quite straightforward. It's like you pass or you fail, and it depends on the others. ESA, which is the European Space Agency, it depends on your nationality too. Because depending on how much money your country of origin gives in ESA, then you might, you might have priority or not. So even if you in the last, say, 10 best people on the whole candidates, depending on, how much money your country gives, then you might not make it. So it's study the thing. So the tests that you do, per se, are those cognitive tests. And if you want to learn more about them, I'm going to write the name of Tim Peake, who's an astronaut. And he wrote a book on the astronaut selection process. So you can find it online easily. And in Russia, I don't know all those the requirements. A few years back, when I looked at what Roscosmos was looking for, they were doing massively extreme tests, like medical tests and sport tests. So that was quite impressive, really, what they were asking of. But psychology and everything, I don't really know. So it's not necessarily well talked about. And Canada has a partnership with NASA. So actually the recruitment process is quite similar. I talked to a Canadian astronaut 2 years ago here in Cambridge, and she told us that at some point, one of the tests was just a resilience test. They had to solve puzzles, then they had to climb ladders and get stuff, and it lasted for hours. And at random moments, they would turn off the light. So you're on a ladder like 5-6 meters above the ground, and you have to grab something, and you have to do it really quickly, and suddenly somebody turns off the light, and it stresses you, and they just wanted to see who was going to give up first. We had other talks with people from you knew people from NASA, but I can't say if it's true. I mean, it's not a first-hand tale that they get maybe, that you put a bag on them, you put them underwater or something like that, kind of tough psychological tests. But I can't testify that it's true. I don't know. It could be, but, we don't know. How do astronauts mentally prepare to live in space? So from my experience is you just get really busy. Okay, so if you were to be now in the ISS, you might start stressing when you realize that this thickness is what separates you from the void of space and what is going to kill you if there's a big hole in there. Okay, it's this kind of stress you can prepare for partly by doing extreme environment training, where you teach to stay calm in the face of danger, and partially you also stay busy. Okay, when you are waking up at 6:30 in the morning and you have to work till 10 p.m. By work, I also mean eating and sports, etc., because all of these are also monitored and you learn something from them. You don't really have time to think that you are in danger. Okay, and this is quite important. If you look at the schedules from astronauts, they barely have any day off. And it's not only because the mission is so busy and you need people to be always awake to maintain the base and make sure everyone's safe. It's also because it's better not to think too much about where you are. Okay. Analogue Space Mission helping to prepare astronauts for deep space or far from solar systems. So deep space and Moon and Mars missions, what do they have in common? Duration. Okay, so if you have a very, very long mission, then you can simulate a very, very long travel. Okay, so this is the main way you can simulate, but it's difficult to say when we would need to prepare for long, deep space missions. So for the moment, we're not aiming for this. For the moment, we need to get to the moon and then get to Mars and see if we can settle there, because if you go to Moon and Mars, you can come back. Probably even Mars is a bit limited. If you go to deep space, you're not coming back. Okay, well, at least not with the technology we will have in the next 20 to 30 years. So psychologically, it's probably going to be extremely hard. And it's the only life that you will see, or at least what we think, is the one that is on board with you. Okay, or if there are kids on board or whatever, then yeah, maybe you see new life, but it will just be what's on board with you. And this psychologically is not something that we've done yet. And I'm not sure how Analogue Space Mission will be able to train us for this. Maybe by doing virtual reality and really pretending that you're sending someone away for a year. Maybe, but ethically, I don't think it would be approved right away. So yeah, sorry, I can't answer much about this because it's not something that is right now a hot topic, but it's very true that, you know, as soon as we get to Mars and we get the technology to go further and further, then this is going to be something that is going to be discussed quite a lot. Cool. Yeah, it would be cool if India had a small space station in 2030. Yeah, and I mean the ISS is going to be decommissioned soon, probably. So, so on the ISS, the experiments that are being carried out are not proposed by analog astronauts. They're proposed by scientists or pharmacies or things like this that need the testing of those drugs. Okay, so for example, in analog space missions, it can be you decide what you want to test, or it can be proposed by universities that are interested in testing this. But on the International Space Station, it's nothing to do with analog space mission. It's a real space mission. You have microgravity, so you're going to test other stuff. You might test the experiments you will have on the ISS on Earth on analog space missions before you send it, but it is not an analog space mission experiment per se. Okay, I hope that makes sense. And yeah, cool. I belong to 4 countries. So my dad was Italian, my mom was French and British, and I grew up in Switzerland. So I've got 4 passports. So I can decide which country I can go, and I would pick Switzerland because it's the one that's closest to my heart. And Switzerland has only 1 astronaut, male astronaut. So it would be amazing if it could be a female Swiss astronaut. That would be absolutely lovely. Okay, so I'm gonna leave now because I have to go back to work, but it was lovely. You guys were just amazing. Thank you so much for all the questions, for the attention and your love for space, or if you haven't done that, I hope it really sparked something into you guys. And yeah, Manish, I hope it's okay if I leave now.
Yes, sir. Yes, ma'am. Sure. Thank you for your wonderful presentation and helping us all out and taking this much time and spending your precious time with us. Thank you, ma'am. And yeah, I think we can end our session here.
Perfect. Well, take care, everyone. Have a lovely, evening. I guess it's evening for you guys. So good night or good evening, and take care. Keep loving space. Okay.